Secant. Okay, what do I remember about the secant? Secant is 1 over the cosine, remember? Identity from way back. And I'd much rather play with sines and cosines. I'm more familiar with them. So I could rewrite this right here as 1 over the cosine of 5x minus 5 equals 0. Once I have a variable in the denominator, there's going to be values that can't happen. So for example, in this case, if the cosine of 5x is ever 0, I don't have a solution. So just a note, cosine of 5x can't be 0. If it is, I have 0 in the denominator and I have a problem. When is the cosine 0? The cosine is 0, x is 0 in the unit circle at pi over 2, 3 pi over 2. So if this 5x were a pi over 2, I'd have a problem. So if 5x equals pi over 2, we have trouble. So if x equals pi over 10, we have trouble. So let's hope that doesn't pop up as a solution. All right, we need to get the cosine out of the denominator, so I would just multiply everything by cosine. So cosine divided by cosine is 1 minus 5 cosine of 5x, and anything times 0 is 0. So that is where I'm at right now. So we had to rewrite, get rid of the secant, then clear the denominator. We have 0 on one side, but there's nothing factorable here, and there's no squares. So this is just kind of an ordinary situation. I would subtract the 1 over and then divide by -5. So cosine of 5x, set to subtract the 1 over, divide by -5. So it was 1/5. And then, so one solution would be applying the arc cosine. So 5x is equal to the arc cosine of 1/5. And the unit circle applies to this part right here, not once I solve for x. That changes the period. So if I want to think about unit circle for a minute, x equals 1/5 would be about here. So there's a solution over there. So this angle right there is that arc cosine. Oh shit, that's a y value. Sorry, wrong way. X equals 1/5 would be here. So that gives me this point up here. That's where the angle the arc cosine is going to find. And then there's another point down here. And I want positive solutions. So to get to that point, I want to sweep around this way. So that one's going to be 2 pi minus arc cosine. So then I worry about dividing by 5. So my first basic solution is x equals arc cosine of 1/5 over 5. X2 is going to be this one divided by 5. So 2 pi minus the arc cosine of 1/5, all divided by 5. And then to generate other ones, I add the multiples of the period. So make a note of the period up here. Period is 2 pi over 5. So the next solution, x3, will be whatever x1 is plus 1 period, 2 pi over 5. And then the solution after that, x4, is going to be the second solution plus the period. So here, I'm just adding the period to get another solution. So those should be the first 4 smallest positive solutions. Let's check that out on a calculator. Clear this. Don't they have a reload button here? What's that do? Share, nope. Undo, I guess, or that. All right, so original one was, oops, secant of 5x minus 5 equals 0. So let's take a look at that. Secant of 5x minus 5. Whoa, lots of solutions there. And so let's see, I'm going to call this f of x equals, and I want the first 4 positive ones. So equals 0 would be the y-axis. So let's zoom in, yes. So 1, 2, 3, 4. Let's see if we got the right one. So we think one of them, I'm going to call that A, should be the, let's see, what was that? Arc cosine of 1/5, and then divide that by 5. So 0.27388, blah, blah, blah. Should be this one, 0.274, they rounded. All right, my other one, B, was a fraction with a 5 in the bottom, and in the top it was 2 pi minus that arc sine. So 2 pi, or arc cosine, sorry. .9827, should be this one. 0.983, yep, just rounded to 3 decimal places. And then we use the period of the original function to get other ones. So the period's 2 pi over 5. So if I take 2 pi over 5 and add that to my solution A here, 1.531 should be this one. And there it is. And then period 2 pi over 5 plus my other solution B, 2.239 should be, let's see, 1, 2, 3, 4, this one right here. There it is, cool, we nailed it, checked on the graph. And here, and give answers accurate to 2 decimal places, cool. Anything else? Trig functions are not allowed, so I wouldn't be able to type the arc cosine as a solution. I have to enter the decimal version, separate them by a comma. All right, got it.